Problem 2 gives us a rear window of a station wagon with a length of, with a wiper blade of 16 inches. And the wiper blade is on an arm of 22 inches, 6 inches from the pivot point. I drew a new diagram, and it looks something like this. And what I illustrated here is the right here being the pivot points of the wiper blade, this right here being the wiper blade, and this being the space of the arm before it starts on the wiper blade right here. And then we have the radius of the point from the pivot point to the end of the wiper blade being 22 inches. What we need to find for part A is if the wiper turns through an angle of 110 degrees, which I highlighted here, we need to find the area that the wiper blade actually wipes. So I highlighted that in red over here, and to find that, we basically have to find the area of this whole sector minus the area of this sector, and what's left over is the area of this sector, and we'll be able to that'll give us the area of the wiper blade. So you can see where I highlighted it down here. We use our area of a sector formula when theta is in degrees. So area equals theta degrees over 360 times pi r squared. And we go ahead and fill that in for each sector. So we have 110 over 360 times pi times 22 squared, noting that we're using 22 for this whole sector, minus 110 over 360 times pi over 6 squared using this radius. And we plug that into our calculator, and what it spits out is 464.6 minus 34.6, which is 430 inches squared. The next thing that we have to do is figure out how much of an angle the wiper would sweep if the area that was clean was 10 square inches. So there's a couple ways to do this. So the way I started doing it was understanding that the area of a rectangle, which is essentially what we're looking for, it's part of a circle, which ends up being a manipulated rectangle, is gonna look something like this, where the length of this, well, it's just some polygon, where the length of this side is theta degrees over 360 times pi d, or pi 12, pi with d being the diameter of the smaller inner circle, and then this being pi, or theta over 360 times pi 44, with 44 being the diameter of the larger circle. And then we know that the area of a rectangle is length times width, and then we know that the length is going to be the radius, which is 16, which is 16x equals 10, which means it needs to be multiplied by 5/8 to cover an area of 10 inches. Now the problem is that this is not 5/8 and this is not 5/8, but what you have is the average of these two is 5/8. And you can look up the theory of how to prove the area of a circle is pi r squared if you're interested in kind of understanding this rectangular to circular theory and how area works in a circle. But just in case you don't trust me, we'll go ahead and solve it later. But what I ended up doing is multiplying pi times 12, dividing it by 360, and then you end up getting some value times theta. That value is 0.104. And then for, I do the same thing for down here, pi 44 over 360, which gives you a value 0.384 theta. And then you find the average, so add them together and divide it by 2. And then what you get, when you set it equal to 5/8, or 0.65, is theta is equal to 2.56 degrees. Now, if you don't believe me with the rectangular theory, you can also do it this way by just saying that theta over 360 times pi r squared, being the radius of the larger circle, is equal to 4.22 times theta, and then theta over 360 times pi r squared, with 6 being the radius of the inner circle, is 0.31 theta. And then we know that the area is or the area of the wiper blade being covered is the area of this minus the area of this. So we just do 4.22 theta minus 2.31 theta, and what you end up getting is 3.91 theta is equal to 10. Divide both sides by 3.91, and what you get is 2.56 degrees for theta. Now, if you wanted to check the rectangular theory, you can just type in 2.56 there. You can see, well, one, you can see that you would get the same answer, but we get, if you plug in 2.56 for theta here and 2.56 for theta here, what you end up getting is 2.68 for this value and 0.3840 or 3.98 for this value, and then the average, if you average them out, would be 5/8. Moving on to part C, it asks us to, it says if a bug A lands at the end of the blade furthest from the pivot, assuming the wiper blade is still going through an angle of 110, how far is it traveling on one cycle? So that's 1 back and 1/4. And then we'll go ahead and talk about part D right now too. So it says a bug B lands at a part of the wiper blade closest to the pivot. So bug A is going to land here, bug B is going to land here. How far are they traveling? And then part E is going to say if a bug somewhere in here travels 28 inches back and forth, where is it exactly on the wiper blade? So we'll go ahead and figure out for part C. All we have to do is do 110/360 times 2 pi times the diameter, because we're basically finding the length of the arc covered on the outermost circle, and plug it into your calculator, and what you get is 84.48 inches. Or sorry, what you get is 42.24 being the length of the arc, but you have to understand that what it's asking for is how far does it travel in one cycle. So it travels one arc and then back again another arc, so you multiply that arc times 2, and what you get is 84.48. We do the same thing, except this time for the inner circle with a radius 6, and what you get is 11.52 for one arc. Multiply that times 2, and you get 23.04 inches. To find out where bug C is somewhere on the wiper blade arm, we know that he's traveling 110 degrees, and that the arc that he's covering is 14, because that the distance he's covering is 28. We've already discussed that the distance he's covering is 2 times the arc, so the arc is just 14. We set our equation equal to 14, 110/360 times 2 pi, and this time we're solving for r, and we know that he is 7.29 inches from the pivot point, but the pivot point is 6 inches from the wiper blade arm, so if we subtract 6 inches, and we get 1.29 inches up the wiper blade arm is where bug C is. That's it, thanks.